Hi, now I want to talk more about ellipses, these orbits that are in the shape of an ellipse, and kind of what that means for planetary mechanics or mechanics of orbiting bodies. So, since Kepler saw it in the math, I think I mentioned Isaac Newton proved that orbits would be elliptical, and that's the case. So, any stable orbit is in the shape of an ellipse. You can have some unstable orbits, those are like things that enter our solar system at high speeds and just zip around the sun. And those follow a hyperbolic path, so it's a little bit different. But for anything in a stable orbit, an orbit that is continuous, periodic, that orbit will be in the shape of an ellipse. Now let's talk about some of the consequences of that. The object being orbited, for planets that would be the sun, is located at one focus of the ellipse. So I've drawn that here. I've just drawn a fairly eccentric orbit, or sorry, an elongated ellipse. This is exaggerated. The Earth's orbit doesn't look anything like that. That could be the orbit of a comet, though. And by eccentric, it means really elongated. So comets have the most eccentric orbits. They're really long. But all orbits are elliptical, so there's some of this elongation occurring for any orbit. If you just look at this path, the sun's at one focus, there's nothing at the other focus. But just the geometry shows you that the distance between a planet and the sun is constantly changing. So if the planet's located here, it's really close to the sun. If it's located over here, it's very far from the sun. Okay? That's not what causes seasons on Earth, because Earth's orbit is almost perfectly circular, but it is conceivable on another planet with life that this would cause kind of another seasonal cycle. So the part of the year where the planet is closer to the sun would be warmer than the other part of the year. Okay, the seasons are caused by the tilt of the Earth, the axial tilt. And I think you've learned that in other science classes.